Today we're going to be looking at trigonometry from Unit 6. This is one of the big ideas in mathematics. There's entire courses that are devoted to this concept. We're just going to be kind of dipping our toes in it and seeing what we get. So we have vocabulary for this section. Go ahead and take a look at your vocabulary sheet to help you out. We will also be splitting the section into 2 days. So let's take a look at our first idea. So trigonometry ratios. So we have sine, cosine, and tangent. And then we have our capital letters and we have our lowercase letters that are going to help us set that up. So if triangle ABC is a right triangle, then the sine of each acute angle in triangle ABC is the ratio of the lengths of the leg opposite that angle to the length of the hypotenuse. So for sine, so if we're looking at angle A right here, it's going to be opposite that, which is the little a, over the hypotenuse, which is the C. If we're at angle B right here, it's opposite angle B, which is lowercase b, over the hypotenuse. So opposite over hypotenuse lets us know what sine is. Cosine. If triangle ABC is a right triangle, then the cosine of each of the acute angles in triangle ABC is the ratio of the length of the adjacent to the angle of the length of the hypotenuse. So where sine was opposite, cosine is adjacent. So if we have cosine of the capital letter A, adjacent to that, right next to that is B over the hypotenuse, which is C. Cosine of B, adjacent to that is the little a over C. Our third idea that we're going to look at is tangent. If triangle ABC is a right triangle, then the tangent of each acute angle in triangle ABC is the ratio of the length of the leg opposite the angle to the length of the leg adjacent. Opposite over adjacent. Ooh, that's a lot. But let's try out a problem and see what we do. So we want to find sine J, cosine J, tangent J, sine K, cosine K, tangent K. And we're going to express each of them as a fraction and as a decimal. So we have sine J, cosine J, tangent J. Then we have sine K, cosine K, and we have tan K, tangent K. So again, sine is opposite over hypotenuse. So opposite over hypotenuse. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And tangent is opposite over adjacent. Opposite over adjacent. So let's just focus on one of them. Let's just focus on J right here. So here's our J. So opposite J is going to be 5. Our hypotenuse is 13. So this is going to be 5 over 13, which is about, when we do the division, 0.38. Okay, again, we're sticking with J. Adjacent. Adjacent is going to be the 12. So this is going to be 12 over the hypotenuse, which is 13 over 13, which is about 0.92. Tangent of J. So tangent is opposite, which is 5. So that equals 5. Over adjacent, which is 12. Over 12. Which is about 0.42. So J is done. Let's take a look at K. So for K, I'm going to start off with my opposite, because I'm doing sine. So opposite of k is 12. Opposite of k is 12. The hypotenuse is still the same because it's the same triangle. So that's going to be 12 over 13, which is about 0.92. Now let's do cosine. Again, we're doing k, so the cosine of k, so adjacent to k is 5. So this is going to be 5. Hypotenuse is still the same. Hypotenuse is still 13. So 5 over 13, which is about 0.38. Now let's do tangent of k. So tangent is opposite, which is 12, over adjacent, which is 5. So that is about 2.4. So we set it up, sine, cosine, tangent. We find our letter, J or K, and then we start working around from there. Opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. So we're using the key concepts a lot to help us out here. Let's take a look at example 2. So in example 2, we have our triangle. In this triangle, we have our right angle right here. We have that this is 60 degrees, and we have that this is 30 degrees. So this is also going to be 2x. This is going to be x, and this is going to be x square root 3. Okay? So we have this information. So we want to use the special right triangle to express sine of 60 as a fraction and as a decimal to the nearest hundredth. So instead of just saying whatever angle, sine j, sine k, we're now going to put in a value in there. So it's going to be sine 60. Sine is opposite over hypotenuse. So sine 60 is right here. So opposite that is x root 3. So sine 60 x over root or times root 3. And then hypotenuse is opposite going to be this. That's 2x over 2 times x. Well, 2 times x and x, those are going to cancel, or x's are going to cancel. That just leaves me with square root of 3 over 2. So there is my fraction, and my rounded is going to be 0.87. Again, 2 times x, x times 3, because these are both times. I can cancel both of these away. So I can cancel this away with this. That just leaves me with root 3 and 2. Let's take a look at example 3. So in example 3, this is where we come into trigonometry the most. We see these types of problems. So we build a ramp so we can access the back door of the house. The 12-foot ramp slopes upward from the ground at a 4-degree angle. What is the horizontal distance between the foot of the ramp and the house? So we want to find this distance right here, and then we want to find the height as well. So what is the distance between the house and the end of the ramp? And then what is the height of the ramp going to be? So to do this, so we have 4 right here. So we have opposite this, and then we have hypotenuse. And then we also have adjacent this, and then we have hypotenuse as well. So since we have adjacent over the hypotenuse, that's going to be cosine. So cosine of 4 equals adjacent over hypotenuse. So adjacent over hypotenuse, that's going to be cosine of 4 equals x over 12. Multiply both sides by 12 gives us 12 cosine 4 equals x. We'll type that into our calculator and we get x equals 11.97. So now we have x, so we know that this is 11.97. We need to find y, and we know this is a right angle, so we're going to use a squared plus b squared equals c squared. So go ahead and plug in what we have. So my y, so it's going to be y squared, plus b squared is going to be 11.97 squared, 11.97 squared, equals c squared, which is 12 squared. So 11.97 squared is y squared plus 143.3 equals 144. So subtract that from both sides. So you get y squared equals 0.7. Take the square root. So square root of 0.7. So y equals the square root of 0.7. So y equals 0.84. So this is our first introduction to trigonometry. So take a look at the key concepts and then review through the notes as you work on the problems today.